Welcome back to CADMech. Every wild project I've built started as a drawing on a screen. But if that drawing is wrong, you end up with a pile of useless parts. Today, we're diving into the most common mistakes fresh engineers make in mechanical drawings and how to avoid them. There's a big difference between a cool 3D model and a drawing a machinist can actually use. We'll break down the 7 deadliest sins of mechanical drawings with real-world examples and fixes. Let's get started. First up, let's talk about one of the most common and costly mistakes in engineering drawings: missing or incorrect dimensions. If a dimension isn't shown on the drawing, for all practical purposes, it simply doesn't exist. The shop floor can't read your mind. Machinists can't guess your intent or fill in the blanks. They rely on your drawings to be complete and unambiguous. Missing just a single number can turn a $500 part into useless scrap, wasting time, material, and money. It's a mistake that's all too easy to make, but expensive to fix. But redundant or conflicting dimensions are just as bad. They create confusion, lead to tolerance conflicts, and can cause costly errors during manufacturing. Always dimension from a logical baseline, focusing on the most critical features. This helps ensure accuracy and makes the machinist's job much easier. Don't just scatter numbers everywhere. Your dimensions should tell a clear, logical story about how the part is to be made. Every feature needs one, and only one, clear path to be dimensioned. No more, no less. This avoids confusion and ensures every detail is accounted for. Before sending a drawing out, always ask yourself, can a machinist build this part using only these numbers? If the answer is no, go back and fix it. Developing this habit will save you time, money, and countless headaches down the road. It's a small step that makes a big difference. Remember, clear, complete, and non-redundant dimensions are your best friend. Never assume anything. Clarity is everything in engineering. One missing or extra number can ruin an entire project, leading to delays, rework, and frustration for everyone involved. So, always double-check every drawing before release. A careful review now can prevent major problems later. The next big mistake people make is not using standard symbols. It might seem harmless to sketch your own marks or shorthand, but this can lead to confusion and costly errors down the line. Engineering drawings are meant to be a universal language. No matter where you are in the world, the symbols should mean the same thing. Don't try to invent your own system or rely on local habits. Always use established standards like ASME, ISO, or DAN for things like surface finish, welds, and especially for geometric dimensioning and tolerancing, or GD&T. These standards are recognized globally. A proper weld symbol or surface finish callout can pack a huge amount of information into a tiny graphic, saving space and making your intent crystal clear to anyone reading the drawing. GD&T symbols control the form, orientation, and location of features far better than written notes ever could. They remove ambiguity and ensure everyone is on the same page. Using standard symbols makes your drawings look professional, unambiguous, and easy to interpret, even for someone seeing them for the first time. Get the standards manual and use it as your reference. Don't just guess or assume you remember the right symbol. It's worth double-checking. The right symbol means your part gets made correctly, whether it's in your local shop or halfway across the globe. Consistency in symbols ensures quality and repeatability. Don't leave anything to chance. Missing or unclear symbols can lead to mistakes, delays, and expensive rework. Learn the language of engineering symbols, and your drawings will always be understood, no matter who's reading them or where they're made. Consistency and clarity are absolutely key. Mastering standard symbols is the foundation of great engineering communication. Poor tolerancing is an expensive rookie mistake. Too tight and you drive up costs. Too loose and parts won't fit. Only apply tight tolerances where function demands it. Understand fits clearance, interference, and transition. Don't use generic tolerances for everything. Specify what matters. Design for manufacturability, generous where possible, precise where needed. Smart tolerancing saves money and ensures your parts work together. Always think about how your part will be made. Good tolerancing is the mark of a pro. Sectional views reveal internal features, but only if done right. Choose cutting planes that show the most useful info. Don't just slice down the middle. Use correct hatching to distinguish parts. Never hatch everything the same. Don't section standard parts like bolts or bearings. Show them whole. Section views should clarify, not confuse. Ask, does this view make the part easier to understand? Follow conventions for clarity. A good section view is a window into your design. Overcrowded, unclear drawings are a nightmare for anyone trying to interpret them. When every inch of the page is packed with information, it's almost impossible to find what you need quickly. It's like searching for Waldo in a sea of lines and numbers. Don't cram everything onto one sheet. Spread your information across multiple sheets for clarity and organization. This makes each page easier to read and helps prevent important details from getting lost in the chaos. Use auxiliary and detail views to highlight complex or angled features. These focused views allow you to show intricate areas at a larger scale, making them much easier to understand. Group notes together and keep leader lines clean. Avoid crossing dimensions or letting annotations overlap. Organized notes make your drawing more professional and much easier to follow. Use plenty of white space to make the drawing readable. Don't be afraid of empty areas. They help separate different parts and reduce visual clutter. Guide the viewer's eye logically from view to view. Arrange your drawing so that someone can easily follow the flow of information without getting lost. Test your drawing. Can you find key information at a glance, or do you have to hunt for it? If it takes more than a moment, consider reorganizing. If your drawing looks like a mess, take the time to simplify it. Remove unnecessary details, clarify your views, and make sure everything is easy to find. Clarity is king. Make your drawing as easy to read as possible. A clear drawing communicates your ideas effectively and reduces the chance of errors. Remember, a clean, well-organized drawing saves time, prevents mistakes, and helps everyone work more efficiently. Good design is about making information accessible, not hiding it in a puzzle. Don't forget notes and specifications. They're critical. Always specify material, heat treatment, and surface finish. Include a complete bill of materials for assemblies. Every part, every detail. General notes cover instructions like deburring or special inspections. Missing specs can ruin a project, even if the geometry is perfect. Treat your drawing like a contract. Every requirement must be written down. The BIOM is your project's shopping list. Don't leave it incomplete. Notes and specs turn a picture into a real, functional part. Never skip this step. Title block errors can derail everything. The title block is your drawing's identity. Never leave it blank or outdated. Unique drawing numbers prevent mix-ups. Revision levels track changes. Always update the revision and fill in who designed, checked, and approved the drawing. No signatures? It's just a draft. The title block is your drawing's official stamp. Review it every time. 2 minutes here can save weeks of trouble. Don't let a missing detail cause chaos. Avoiding these mistakes is the difference between smooth projects and costly disasters. Always check dimensions, standards, tolerances, views, clarity, specs, and the title block. Consistently clear, complete drawings build your reputation and trust. Take pride in your work. Your drawings are your engineering signature. Like, share, and subscribe for more CAD-MEC tips. Drop your drawing horror stories in the comments. Let's learn together.